Okay, let's unpack this. Imagine a messenger, right? From the
Yeah.
stars, a celestial time capsule traveling for like billions of years, and then suddenly, bam, it just appears in our solar system. That's exactly what we're talking about today.
It sounds like science fiction, but it's real.
Totally real. We're focusing on the interstellar comet 3I Atlas, officially C2023K1, and it's a super recent discovery, spotted July 1st, 2025, by that NASA-funded ADIALS telescope down in Chile.
Right, and then confirmed just a few days ago, July 25th, 2025, around 10:10 p.m. Eastern Time. That's when they knew for sure it was interstellar.
What makes this one so incredibly special, I think, is its status. It's only the third confirmed object we've ever seen from beyond our own solar system.
Exactly. Following One-Eye Oumuamua and Two-Eye Borisov, it's a very exclusive club.
Yeah.
And what's truly fascinating here is how 3I Atlas really is like a cosmic time capsule.
Mhm.
Its orbit, that hyperbolic path, its sheer speed, and its, well, ancient composition, it carries unique clues.
Clues about what, exactly?
Well, not just about how our own solar system formed, but maybe even about the conditions, way back when life might have gotten started across the galaxy, potentially. It's basically a direct sample of history from another star system delivered right here.
Wow. Okay, so our mission for this deep dive is clear. We need to decode the mysteries of 3I Ricolas, its composition, that incredible one-way orbit, and what it all means for space exploration for our understanding of the universe. And hey, if you're like us, always hungry for these kinds of deep dives into really fascinating topics, remember you can find more great information just like this over at Mind Expansion Daily. Definitely check them out. So the story really kicked off just a few weeks ago. Can you walk us through those first sightings? How do we even spot this thing?
Sure. So, July 1st, 2025, the ATLA system, that's the Asteroid Terrestrial Impact Last Alert System, specifically the telescope up in Haleakala, Hawaii, it spots this faint object moving fast.
Just a faint dot.
Pretty much. Initially just designated A11BP7I, and it was moving about 27 kilometers per second. That's, 19 miles per second near the constellation Hydra?
Okay, fast. But how do we know it wasn't just, another asteroid or maybe a comet from our own backyard?
Well, that's where follow-up observations were key. And they happened quickly. Astronomers confirmed it was a comet because they detected its coma.
Ah, the coma, that fuzzy halo.
Exactly. That glowing cloud of gas and dust around the nucleus, that's a dead giveaway for a comet. It means it's active, shedding material. And then by July 25th, enough data had come in analyzing its path, its speed. They could definitively say, yep, this thing isn't bound to our sun, it's interstellar. And that's when it got the official name, 3I-8T-LES.
Okay, got it. So when they first saw it, where was it? And what did it look like?
It was still pretty far out, about 670 million kilometers, so 420 million miles from the sun. That puts it inside Jupiter's orbit, but still way out there. And the really striking thing, it had this distinct greenish hue.
Greenish.
Yeah.
What does that mean? Is that common?
It's not uncommon for comets, but it's significant. It's a chemical fingerprint. That green color is almost certainly from diatomic carbon C2 in its coma, which suggests it's probably got carbon-rich ices. We saw something similar with another comet, C2024S1, actually.
Interesting. And I heard something about older pictures helping out.
Yeah, absolutely. They found pre-discovery images, pictures taken back on June 14th, 2025 by both the Zwicky Transient Facility, ZTF, and ATL itself. They didn't realize what they had at the time, but finding the object in those older images was crucial for nailing down its exact trajectory.
Wow. So this thing is rare, maybe incredibly old.
Potentially very old. Some estimates put it at possibly over 7 billion years old, which is just staggering. It promises some really unprecedented insights into what things were like way beyond our solar system long ago.
But studying these kinds of visitors, these cosmic enigmas, it's not exactly straightforward, is it?
Oh, definitely not easy. Comets are tricky beasts. Their whole composition, ice, dust, rock, makes them notoriously unpredictable.
How so?
Well, as they get closer to the sun, they heat up. The ice turns directly into gas sublimation and carries dust with it. That's what creates the coma and the tail, which is great for visibility, but it causes problems. For one, that cloud can obscure the nucleus, the solid core we really want to see.
Right, makes it hard to measure the actual size and stuff.
Exactly. And second, that outgassing, the jets of gas shooting off, it acts like tiny rocket engines. It can actually push the comet around slightly, altering its orbit in ways that aren't just due to gravity. We call those non-gravitational forces. Makes predicting their exact path tricky.
Yeah, I remember hearing about C 2024 S1, another ATLAS comet. Didn't that one just fall apart?
It did, yeah. It disintegrated before it even reached perihelion, its closest point to the sun, back in October 2024, probably spun itself apart due to the sublimation.
So could that happen to 3I Atlas?
It's always a possibility with comets. And 3I Atlas seems to have a fairly small nucleus. The estimate is somewhere between, say, 0.8 and 11 kilometers
Well,
across.
that's a pretty big range.
It is. It adds to the uncertainty. How active it gets depends on how much volatile ice, like water, carbon dioxide it has near the surface. Plus, just seeing it is tough. It was magnitude 18 when discovered. That's really faint.
Requires big telescopes, though.
Absolutely. Powerful ones. And to make things harder, when it was first spotted, it was against the backdrop of the Milky Way center, Sagittarius. Just tons of stars, making it hard to pick out.
So with all those challenges, why bother? Why put in all this effort?
Because the potential payoff is huge. Despite the hurdles, every single observation, every bit of data we can squeeze out of an object like 3I Atlas, it's a piece of the puzzle, essential for understanding cosmic history, how planetary systems form, maybe even where we came from.
Okay, let's talk more about that journey then, its path. This isn't just any comet looping around the sun, is it?
No, not at all. This is the defining characteristic. Its trajectory is unbound, hyperbolic. The orbital eccentricity, that's the number that tells you how stretched out an orbit is calculated at 6.145, plus or minus a tiny bit.
And 6 is high.
Extremely high. Anything greater than 1 means it's hyperbolic, not bound to the sun. 6 is way up there. It absolutely confirms its interstellar origin. Comets from our own Oort cloud, way out at the edge of the solar system, they might have eccentricities very close to 1, maybe slightly above if they get a gravitational nudge, but nothing like 6.
So it's definitely just visiting. A one-way ticket.
Precisely. It will pass through our solar system just this once, and then head back out into the void, never to return.
And it's coming for the direction of Sagittarius, you said, near the galactic center.
That's the apparent direction, yes.
Mhm.
Near the Milky Way's core, it's heading inwards now. Its closest approach to the sun, perihelion, that'll be on October 30th, 2025. It'll get to about 1.4 astronomical units from the sun. And AU is the Earth-Sun distance, so 1.4 AU, that's about 210 million kilometers, just inside the orbit of Mars.
Okay, so not super close to the sun. And what about Earth? Any danger?
None whatsoever. Its closest pass to Earth will be quite comfortable, about 1.8 AU. That's roughly 270 million kilometers away. So yeah, absolutely no threat.
Phew, okay. And its speed is just incredible 61 kilometers per second relative to the sun.
Blazing fast. Yeah, 61 kilometers. That kind of speed strongly suggests it didn't form around our sun. It must have been ejected from another star system.
Where from, do we think?
Hard to say for sure, but possibly somewhere in the galactic disk, maybe the thicker part of it. It got kicked out, traveled for who knows how long, and just happened to wander into our neighborhood. And that trajectory is so significant because it gives us this incredibly rare chance to study something pristine, something untouched by our sun's heat and radiation until now.
Right. And you mentioned confirming that trajectory.
Yes, cross-referencing the observations with NASA's Jet Propulsion Laboratory, specifically their small body database, was crucial for refining those orbital parameters and confirming just how hyperbolic its path is.
Okay, so if this really is a time capsule, what have we learned about what's inside it so far? What's its composition?
Right, the composition. That's where it gets really exciting. We've been watching its coma and tail develop since discovery. And they clearly show active outgassing. We're seeing signs of water ice sublimating and probably silicon minerals, basically. Fine dust being carried away, too.
Yeah, the green color.
Back to the green color, yes. That's likely the diatomic carbon C2 we mentioned. It strongly hints that there are carbon-rich ices mixed in there, similar, again, to what we saw in C 2024 S1.
And are we expecting to learn more soon? I think I saw some chatter online, maybe on X, about finding really old, pristine water.
Yeah, that's a really hot topic right now. There's some exciting preliminary evidence, hints that 3I Atlas might contain water ice that's basically unchanged since it formed in the interstellar medium. Like water that predates stars inherited directly from those giant molecular clouds.
Wow, like original recipe water.
Sort of. It would make it an amazing direct probe of the raw materials that build planets everywhere. And we have big plans to look closer. Hubble is scheduled to do ultraviolet spectroscopy in November 2025.
What will that tell us?
That'll let us analyze the gases being released in detail, measure things like the ratio of sulfur to oxygen, which can tell us about the chemistry where it formed, and even more exciting, the James Webb Space Telescope, JWST, is going to observe it in infrared light.
When's that happening?
There are observations planned for August and December 2025. JWST is perfect for detecting molecules like water, carbon monoxide, carbon dioxide, even ammonia within the coma. That will be huge for pinning down its composition.
So that ancient water, potentially over 7 billion years old, if confirmed, that means we could literally be looking at the conditions before our own solar system even existed.
Exactly right. It's like opening a window onto the chemistry of the galaxy's past, understanding the ingredients available when stars and planets were first forming long before our sun lit up. It's a direct link to the primordial soup of the universe, in a way.
Incredible. Now, just to be absolutely clear for everyone listening, some might wonder, couldn't this have come from our own Oort cloud? That theoretical shell of icy bodies way out there.
That's a fair question, and it's important to distinguish. The Oort cloud is thought to be this vast, spherical reservoir of icy objects, maybe starting 10,000 AU out, stretching perhaps halfway to the nearest star. And it is the source of many long-period comets we see, like C2023A3, which got a lot of attention.
But 3I Atlas is different.
Fundamentally different. Its orbit, that incredibly high eccentricity, that hyperbolic path, it just screams interstellar.
Yeah.
Oort cloud comets have orbits that are still ultimately bound to our sun. They might be very elongated ellipses, almost parabolic, but the part of our system. 3I Atlas is moving way too fast on the wrong kind of path to be from the Oort cloud.
So it definitely formed around another star.
All the evidence points that way.
Yeah.
Formed in another star system, maybe in the Milky Way's thick disk, got ejected somehow, probably a gravitational interaction with the planet or another star in its home system, and then it just wandered through interstellar space for millions, maybe billions of years.
Just drifting.
Until it stumbled into our solar system by pure chance. And that's what makes it so special. It's a sample of an extrasolar environment. Oort cloud comets tell us about our early solar system, which is fantastic. But 3I Atlas tells us about somewhere else.
Okay, stepping back then. What does all this mean? Why does studying this one far-off comet really matter to us? What are the big picture implications?
Well, think about it. Comets in general are like fossils from the birth of our solar system 4.6 billion years ago. They've preserved materials from that time, relatively unchanged, so studying them tells us about our own origins. But 3 Atlas, being interstellar, gives us a vital comparison point. How did other star systems form? Are the processes similar? Its water-rich nature, if confirmed, might suggest the chemistry in those interstellar clouds is pretty universal.
So, similar ingredients everywhere.
It could point that way. By studying its ices, we can infer what conditions were like in its original solar nebula. And that helps us test our models of planet formation in general. Plus, it might reinforce the idea that comets could have delivered water and organic molecules, the building blocks of life, to early Earth, if similar objects formed elsewhere.
Right. And you mentioned gravitational interactions ejecting it. Does its path tell us anything about its home system?
Potentially, yes. The fact that it got ejected suggests dynamic processes were happening there. Maybe things like planets migrating, shuffling around gravitationally, kind of like how Jupiter's movements likely shaped the early chaos in our own solar system. Studying 3I Atlas's trajectory might eventually give us subtle clues about the architecture of its parent system. It really does, as you said, reshape our understanding of comets as these cosmic messengers carrying news from afar.
Absolutely. But it's not just about history, is it? There are practical implications for the future, for space exploration.
Oh, for sure. Several, actually. First, resources. Comets are full of water ice. For future long-duration space missions, that water could be invaluable. You could mine it for life support, or split it into hydrogen and oxygen for rocket fuel via electrolysis.
Like a cosmic gas station.
Exactly. Understanding the composition of comets like 3I Atlas, which JWST will help with, is crucial for designing the technology to actually extract those resources. Second, navigation. The unpredictable outgassing we talked about, that poses a real challenge for spacecraft trying to rendezvous with or orbit a comet.
Like that ESA mission, Comet Interceptor.
Precisely. Comet Interceptor, launching around 2029, aims to visit a pristine long-period comet, or maybe even an interstellar object if one comes along at the right time. Understanding how these things behave is critical for mission success. Third, planetary defense. While 3I Atlas is passing by safely at 1.8 AU, studying its trajectory helps refine our models for predicting the paths of potentially hazardous objects.
Building on stuff like the DART mission.
Exactly. DART showed we can alter an asteroid's path. Understanding the trajectories of comets, especially long-period and interstellar ones that can appear with little warning, is vital for assessing any potential impact risk down the line.
Okay, now we have to touch on this. With something this cool and mysterious, you always get some,
Mm-hmm.
let's say, fringe ideas popping up.
Yeah.
Has 3i Atlas attracted any speculation?
Oh, inevitably. Yeah, especially on platforms like X, you see some chatter. Some folks speculate it might not be natural. Maybe it's some kind of alien probe exhibiting deliberate concealment.
Seriously.
Yeah, or even suggestions it could be possibly hostile, invoking the dark forest hypothesis from science fiction, which some researchers have actually written papers about in other contexts.
Okay, wow.
Yeah.
But is there any evidence for that? What does the actual science say?
Let's be really clear here. There is absolutely zero credible evidence to support those claims. Zero. Everything we've observed, the coma, the tail developing as it nears the sun, the spectroscopic data showing typical cometary molecules, the green hue from diatomic carbon, and it all aligns perfectly with what we expect from a natural comet.
And its path? No weird maneuvers.
None whatsoever. Its trajectory is perfectly explained by gravity and those predictable non-gravitational forces from outgassing. And its faintness, magnitude 18, is completely consistent with a small, icy nucleus becoming active.
So, while the speculation might be, well, intriguing to some,
It's purely speculative, not supported by the data, not supported by mainstream astronomy. It really highlights how important it is to critically evaluate information, especially extraordinary claims found online, and stick to the evidence.
right, always check the source, check the evidence. So looking ahead,
Yeah.
what's the future for 3i TLAS itself? It's not sticking around, you said.
No, its visit is temporary. By December 2025, as it moves further from the Sun and Earth after its October perihelion, it will fade from view for our telescopes. It'll head back out, leaving our solar system behind on its endless journey.
It might get brighter around perihelion in October, though.
It could, yeah. It might reach magnitude 11, potentially. But the catch is, around perihelion, it will be quite close to the Sun in our sky.
So lost in the glare for us on Earth.
Pretty much. Easier to see from, say, Mars at that point, ironically, but difficult for Earth-based observers.
But the science doesn't stop when we can't see it anymore.
Not at all. The data we're collecting now, especially from Hubble and JWST later this year, will be analyzed for years to come. That data will continue to unravel its composition, hopefully confirming that ancient, water-rich nature we discussed. And long-term, studying 3i Atlas helps us estimate how common these interstellar visitors are. That feeds directly into planning for missions like Comet Interceptor, helping us know what the odds are of finding another one.
It's a powerful reminder then, isn't it?
Yeah.
As a one-time visitor, it really urges us to make the most of these fleeting cosmic encounters.
Couldn't have said it better myself. Seize the cosmic moment.
So let's try and sum this up. Today, July 25th, 2025, we've got 3i Atlas. This celestial enigma, maybe a 7-billion-year-old interstellar comet, offering us glimpses into the universe's dawn.
Yeah, its key features the hyperbolic orbit confirming it's from beyond, its likely water-rich ancient composition, its interstellar origins. They set it apart from our local Oort cloud comets. It gives us this unique window into how other solar systems might form, the chemistry involved, and as we discussed, it really shapes future space exploration, the challenges of navigation, the potential for resources, and even how we think about planetary defense.
And while those speculative claims about aliens add a certain spice, the hard scientific data consistently points to 3i Atlas being a natural, albeit incredibly fascinating, wonder.
Absolutely. Which, leads to a pretty profound thought. If this one wandered in, what else might be out there? Traveling the vastness between the stars, just waiting to drift into our view and share its own ancient story. Makes you wonder, doesn't it?
It really does. Wow. This deep dive into 3i Teal has been quite the journey, hasn't it? If you've enjoyed uncovering the secrets of this cosmic time capsule with us today, we'd really appreciate it if you'd like and subscribe to Mind Expansion Daily wherever you're listening. And hey, we're genuinely curious. What are your thoughts? Do you agree or disagree with our summary of this incredible interstellar visitor? Leave a comment below the episode and let us know what you think. Until next time, keep exploring.